All right, let's look at part 1 of section 5.2. There's a lot to talk about in section 5.2. This is basically kind of an entire graphing unit in one homework section. There are 20 problems, and they range from very easy things like plotting points. And then I like to think about it as 3 ways in which we can graph a line. The first way we can graph is by creating a table. We can also graph by using the intercepts. And then we can use slope-intercept form, which you may remember as y equals mx plus b. But this will be part 1. We will go over the basics of a graph. We will go over creating tables and graphing using tables and using intercepts, finding the intercepts, and graphing by the intercepts. So I have this file that I've used in another class. This has more than we need, but it has some really good some information here. I will upload this in the video section, and I'll be sure to talk about what page I'm on. This is page 2. So let's talk about some terms associated with a coordinate grid. We have 2 axes, the plural of axis. I'll kind of sketch this out as well. The horizontal line is our x-axis, and the axis that goes up and down is our y-axis. Where the 2 axes meet in the center, that is the origin, which is at 0, 0. There are 4 quadrants in the coordinate grid. We use Roman numerals. The only time we use Roman numerals. And this is quadrant 4. So the quadrants go 1, 2, 3, 4. A neat way to remember that is that it makes a C. The path your pen or pencil takes as you make a C, those are the numbers. We have quadrant 1, 2, 3, and 4. So the questions you'll have relating to quadrants is they might give you a very large number, like, well, first of all, let's talk about ordered pairs. An ordered pair is always an x and a y. So our x value followed by the y value. So if we have a coordinate like 1, 2, from the origin, I would go out 1 for the x value and up 2 for the y value. We'll come back to that when we talk about plotting points, but the question you might see in ALEKS is, I think they give you a very large number as an ordered pair, like let's say 500 for the x and 2,000 for the y. What quadrant does that point lie in? And we can answer that because in quadrant 1, both the x and the y are positive. Think about a point like 1, 2. We would go out in the positive direction, which is to the right, where these numbers are positive. And we would go in the positive direction, which is up. Everything above 0 is positive on the y-axis. And so for quadrant 2, we are to the left of the origin. So these are where our negative numbers lie. This would be like -3. So in quadrant 2, the x value is negative, but the y value, we're in the positive land for y values. In quadrant 3, something like -3, -3 would be right here. In quadrant 3, both the x and y are negative. And finally, in quadrant 4, if we're over here, we are in the positive realm for the x-axis to the right of 0, but we are below on the y-axis, below 0 on the y-axis, so that is negative for the y. So in quadrant 1, they're both positive. In quadrant 2, the x is negative, but the y is positive. In quadrant 3, they are both negative. And in quadrant 4, you have one positive, one negative. Positive x, negative y. So let's talk about actually plotting points. We start at the origin, which is 0, 0. 0 for the x, 0 for the y. The steps to plotting points are to determine the x value and move right or left from the origin. Right if it's positive, left if it's negative, just like a number line. To the right of 0, the numbers are positive. To the left of 0, the numbers are negative. And then from the x value, we determine the y value and move up or down from the x value in step 1. And again, if we're moving up, that's in the positive direction. If we're moving down, then we have a negative value. So we'll do one of these. Plot these points. I'll do this one over here. G is at 2, 0. So start at the origin. This is the x value. Remember, an order pair is an x, then a y. So from the origin, we go over 2 to the right. And then the y value is 0. So we don't move up or down at all. So 2, 0 lies on the x-axis, meaning that, and we'll get to this later in the video, 2, 0 is the x-intercept. The next point we'll do is 0, 2. So from the origin, I do not move to the left or right because the x value is 0. But I'm going to move 2 units up. And we should label our points, by the way. That's point H. This is point G. So H is on the y-axis as a point that is 0, 2. And if my x value is 0 and I have a y value, then we are looking at the y-intercept. Let's take a look at the rest of these points. 4, -1 for point I means I move out 4 from the origin, move out 4 units to the right because 4 is a positive number, and then move down 1 in the negative direction for point I. So again, a positive x, a negative y is in quadrant 4. We'll do point J at -5, 3. So from the origin, I move to the left 5 and then up 3 units. And that is point J. And finally, point K at negative 2, 1. Move to the left 2 and up 1 for point K. And now we will look at using tables. This is on page 3 now of this file. Well, let me take a look at these real quick. You'll also have problems in which you label the points from a graph. And so point A, for example, if you make a line going down, we would hit the x-axis at negative 2. So that's where we are at on the x-axis. If I move a kind of a dotted line to the right, we would hit the y-axis at 4. So that means from the origin, we move to the left 2 and up 4 to get point A. Remember that a coordinate, an ordered pair, should be an x value followed by a y value in parentheses with a comma between them. And so then we'll just do the intercepts here. Point D is on the x-axis. If we are on the x-axis, then that is the x-intercept. And so that means we have a value of 2 for the x, and we did not move up or down, so that's a 0 for the y. If I'm on the x-axis, my y value is 0. And then we have this point right here, point B. Point B is on the y-axis, the vertical axis. And if we are sitting on the y-axis, then that is the y-intercept. So I don't move left or right, so that means my x value is 0, and then I have a y value of 3. So if we're on the y-axis, then that is our y-intercept, and x must be 0, and then we have a y value. So we'll come back to intercepts after we talk about tables. You'll be given these problems in which you are given an equation, and you are given x values to plug in, and then you create ordered pairs. So, get a piece of paper. For this first example here, our equation is y equals 3x plus 2. Our first x value to plug in is negative 2. So I replace x with negative 2, and I solve this out. Of course, you could put this in the calculator, but we could talk about order of operations right now. We have to multiply before we add. So 3 parentheses negative 2 means that this is 3 times negative 2 to get negative 6. And if you add 2 to that, negative 6 plus 2 is negative 4. So as an ordered pair, we have negative 2, negative 4. And we'll keep going. For negative 1. I take my function, my equation. I replace x with negative 1. Again, we multiply and then add. So negative 3 plus 2 is negative 1. So as an ordered pair, negative 1, negative 1. And we'll stop at 0 here, because 0 is always a fun one to plug in. 3 times 0 is just 0, which means that this is just 2. So if my x value is 0 and my y value is 2, this is our y-intercept. I'm just trying to plant this seed of talking about intercepts because it's an important concept. And so that's how we create a table. And now from here, I want to show you number 1 in Alex for this section. Your number 1 will look something like this. Well, g of x equals. So let's talk about g of x for a second. We can have equations that start with y equals. They can start with f of x equals, g of x equals, h of x, whatever. These all mean the same thing. It's just a way of, it's function notation, but ACM, the 1332 course that you're in, is not a very function-heavy class. So we just need to know that we're looking at basically y equals 4 over 7x plus 2. And this really won't affect the problem any. This is what the answer blank will kind of look like. Where you are given a table, you are given the x values. We're going to plug them in and see what we get for y. So again, the pieces that will always be given to you are the equation itself and the x values. If you're wondering where these came from, it's just part of the problem. We could multiply like 4 over 7 times, well, again, anything times 0 zeroes out, whether it's a fraction or a whole number. So 4 over 7 times 0 plus 2 becomes just 0 plus 2, or 2. But to be honest, we can use the calculator here. So you can multiply this out like we did on the previous example, or let's talk about the calculator a bit. We have this button called y equals, where we can enter a function like this, a graph. So let's go to y equals. I already had something there, but you probably won't. Remember that f of x, g of x is the same as y equals. So I can change g of x to y, and now we are in y equals. Now you have y1, y2, etc., because you can graph multiple, you can look at multiple graphs at the same time. We probably won't in this class. So I'm going to take this just as it reads. I like to put my fractions in parentheses. 4 over 7. Here's the x button. And then plus 2. So again, this was the y equals button. And then I typed in this information. So from here, we can look at the graph by hitting graph. That's what this looks like. We start with the y-intercept of 2, and then we follow our slope of going up 4 and over 7. I'll talk about slope on the next video. But here's what I want to show you. That's the graph, but if I hit second graph, it pulls up the table. And now we have this table. And we're dividing by 7, so we're going to get some weird decimals here. But look at the values we want to, well, evaluate. When x is 0, y is 2. So we move our cursor up and down the x column here. So you might need to move your cursor around to find, at first, 0, and then we're going to see what is the y value when x is 7. When x is 7, y is 6. What about when x is negative 7? Well, we're in the positives right now, so I need to scroll up, and I'm just hitting the arrow keys until we get to negative 7. When x is negative 7, y is negative 2. So, again, we go to y equals. We have to be solved for y, and I'll talk about that in a next example. But I type 4 over 7x and then plus 2. And I hit second graph to pull up the table. And then we just scroll up and down along the x column until we find these values. So, let me show you real quick. Without thinking about it as a graph, just thinking about what we have in front of us here. Let's take 3x plus 2 into my y equals. And now I hit second graph. When x is negative 2, y is negative 4. Negative 2, negative 4 is an ordered pair. So this is also a way to check yourself if you want to do it by hand. Negative 1 is an ordered pair, just as we found. And then we should see 0, 2 right below this. And we do. So, one more example. Example 2, this is page 5 of the document that I will upload in the video folder. So, look at something like number 2. We have 3y equals 5x plus 15. If I go to y equals, there's no way to type in so much glare. There's no way to type in a coefficient of 3 in front of the y. We have to be solved for y. All that means is that we're going to divide everything here by 3. And now y is by itself. I have 5/3 x plus 15 divided by 3 is 5. And now I can go into y1 and do 5/3 times x plus 5. Go to my table, and there we are. We're at negative 6, which is where our table starts. When x is negative 6, y is negative 5. When x is negative 3, y is 0. So that means this is our x-intercept. When x is 0, y is 5, meaning that's our y-intercept, etc. 310 is a point on this table, as is 615. So that's tables. Honestly, you can just use the calculator, type in your equation. Once it is solved for y, hit second graph to find the table, and just move the x. Move your cursor up and down the x column to find the values that you want. Alrighty. The last thing we're going to talk about in this video is the notion of intercepts. I've already been talking about it a bit. This is page 9 of this document. So, as I've been pointing out each time, one way to graph a line is if we know what the x-intercept is and we know what the y-intercept is, we only really need 2 points to graph a line. So we have no room for error here because we're only going to be finding 2 points, but this is a perfectly good way to find, to graph a line. A point that crosses the x-axis, or I think about it as sitting on the x-axis, crosses the x-axis when y equals 0. So for an x-intercept, you have an x value and y is 0. Our y-intercept is a point at which the graph crosses the y-axis when x equals 0. So if we're on the y-axis, then our x value is 0, and we have a y value. So looking at this problem here, we'll take a look at this one. It's a little easier to see. What are the intercepts? An intercept should be an ordered pair with an x value and a y value separated by a comma in parentheses. Of course, in ALEKS, sometimes the parentheses are like included for you, so you don't want to insert a double set of parentheses and get it wrong. Sometimes it just wants the value. So here's our x-intercept. Here, each hash is, they've only labeled the even numbers. So -1, 2, 3, 4, 5. We're hitting the x-axis at -5. And if we're on the x-axis, then we would not move up or down any. So our y value is 0. My y-intercept, I'm hitting the y-axis at 4, which means we did not move to the left or right any. If I'm on the y-axis, my x value is 0, and then we have this y value of 4. So let me turn the page. Yeah, this one. This is page 10 of this file. Here's where it's really handy to use the intercept method when we have something like this, where it's the x term and the y term separated by a plus or minus sign equals the constant. Just the number, no variable attached. To find the x-intercept, that's where y equals 0. So I plug in 0 for y. A lot of teachers just don't even do this part. They just know or tell the students that we know that the y is zeroed out. The y term goes away when we plug in 0. Because we really just have 3x equals 24. 4 times 0 is 0, so it goes away. And now we just divide out our coefficient. And we get x equals 8, but we need to make it an ordered pair. I'll do the same thing for the y-intercept. When I'm on the y-axis, my x value is 0. So I take my equation, I replace x with 0. And if you want to skip this first step and go straight to 4y equals 24, that's fine. In case there's any confusion, 3 times 0 becomes 0. So it's 0 plus 4y equals 24. And we kind of drop out the 0 and go straight to here. So that's like the missing step, in case you needed it. But changing x to 0 means the x term goes away, and now it's just 4y equals 24. And that would cancel when we divide both sides by 4, and we get 6. As an ordered pair, 0, 6. So you could try number 3. That's the same kind of problem. It's going to divide out nicely. And then, what else? Oh, yes, last problem here. Let's look at actually graphing using intercepts. So this is page 11, example 4. This is a good problem here. So we have 3x minus 4y equals 12. I want to first find my x-intercept. So if I'm on the x-axis, my y value is 0, which becomes, that goes away, so 3x equals 12. Divide both sides by 3, and we get 4. As an ordered pair, 4, 0. And let's do the y-intercept. If I'm on the y-axis, my x value is 0. But we get a y value. 3 times 0 goes away. Now we have negative 4y equals 12. Divide both sides by negative 4. Now our y is by itself. Positive 12 divided by negative 4 is negative 3. So 0, negative 3 as an intercept. And now I'm going to plot these points. So I have 4, 0, and 0, negative 3. So from the origin, I move out 4 units to the right, but I do not move up or down, and that's our x-intercept. For the y-intercept, we do not move left or right, but we move down 3. And then if we connected these, again, we connect our 2 dots. Oh, and Alex, if you've never done it before, you first plot the points with like, I think it's like, well, I don't remember what the point plotting tool looks like. Maybe it's just a point. But then you have this kind of weird little asterisk thing with a bar. This is your line tool. So you plot the points, and then you take your line tool, and it will go through both points. So that is what graphing using intercepts looks like. It's really handy when it's in this form, where it's the x term, ax, plus or minus the b term, by, equals the constant, the number. When it's in that form, it's really easy to use the intercept method. So like something like number 5, you might want to move over that 6x. And now we're in the form that's very easy to use, the intercept method. Really doesn't matter if the x or y term comes first, because we're just plugging in zeros. So that's it for part 1. I'm going to record and upload all of these today, Tuesday. So next I'm going to do a video on slope and graphing using the slope intercept method. So let me know if you have any questions. Hope that helps.